Hello, everybody. I'm back along with wrong angle, Miss Kitty. We are back, and we're doing Python Crash Course again. And this time we are moving on to Chapter 9, I believe, today. Yes, Chapter 9 is our next chapter we are moving on to. Um, my goal was to finish the book by the end of September, but that doesn't look like it's going to happen. And that's okay. It's you never want to beat yourself up over, you know, I did a lot of work this month. I probably could have done more, but that's okay. I'll try better next month. It's not. I'm not here to bully myself into this. This is a hobby. I'm treating it as a hobby that might eventually lead to something in the future, in career wise. But hobbies should never be taken too seriously, or she'll just burn out of them. So, classes. Chapter 9. So, in the previous chapter, we learned about functions and we learned how to, input arguments into functions. We know how to actually how the functions work. We learned how to have users provide use the functions given and import them into files, pre-existing functions, have them also be able to use those pre-existing functions dynamically in their own approach to set keyword arguments or just arguments inside of their function, in various arbitrary using the asterisk operator and things of that nature. Let me go ahead and pull up the chat just in case someone joins and chats it up in here. Most likely not, but it's okay. All right, chapter 9, classes. Let's go and jump into this, Miss Kitty, huh? Let's jump into this thing. All right, object-oriented programming, OOP, is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. You create objects based on these classes. When you write a class, you define the general behavior that a whole category of objects have. So I've learned about classes a little bit before. I do have experience with classes because I have completed Python CS50P, but I am using this as another resource to further solidify my knowledge. So I know, the general gist of what classes are. I've programmed with them before, but I really wanted to learn the actual ins and outs because I feel like in that course they skim over things very quickly, and I found myself having to go back and rewatch just to kind of understand basic concepts because it moved very fast. And I think that's just because the Professor David, he's a great professor, but he's also very knowledgeable. And sometimes he can kind of skip over things that a true beginner would get caught up on. Uh, when you create individual objects from the class, each object is automatically equipped with a general behavior. You can have you can then give each object whatever unique traits you desire. You'll be amazed how well real-world situations can be modeled with object-oriented programming. Making an object from a class is called an instantiation, and you work with instances of a class. In this chapter, you'll write classes and create instances of those classes. You'll specify the kind of information that can be stored uh, in instances, and you'll define actions that can be taken with these instances. You'll also write classes that extend the functionality of existing classes so similar classes can share common functionality, and you can do more with less code. You'll store your classes in modules and import your classes written by other programmers into your own program files. Learning about object-oriented programming will help you see the world as a programmer does. You store your classes in modules and import classes written by other programmers into your own files. Okay. Um, yeah, we learned about modules in the last chapter as well when I talked about importing functions from other files, or modules that have functions. Uh, it'll help you understand your code, not just what's happening line by line, but also the bigger concepts behind it. Knowing the logic behind classes will train you to think logically. You can write programs that effectively address any problem you encounter. Classes also make life easier for you and the other programmers you'll work with as you take on increasingly complex challenges. When you and other programmers write code based on the same kind of logic, you'll be able to understand each other's work. Your programs will make sense to the people you work with and allowing everyone to accomplish more. Creating and using a class. You can model almost anything using classes. Let's start by writing a simple class, dog, that represents a dog. Not one dog in particular, but any dog. What do we know about most pet dogs? Well, they all have a name and an age. We also know that most dogs sit and roll over. Those two pieces of information, um, name and age, and those two behaviors, sit and roll over, will go into our dog class because they are common to most dogs. This class will tell Python how to make an object representing a dog. After our class is written, we'll use it to make individual instances, each of which represents one specific dog. Each instance created from the dog class will store a name and an age and will give each dog the ability to sit and roll over, which are functions. That's how it's listed. Sit with parentheses, roll over. Okay. So we have class dog. We have class dog in line 1. A simple attempt to model a dog in the notes. So you def init. So you initialize when you initialize the class, you initialize the class itself. Then you give the name and age attributes. Self.name equals name, self.age equals age. Line 4, or footnote 4, def sit takes in an instance of self, the instance of the class, simulate a dog sitting in response to a command. Print self.name is now sitting. Def rollover, okay, so same thing as rollover. There's a lot to notice here, but don't worry. You'll see this structure throughout this chapter and have lots of time to get used to it. We first define a class called dog in footnote 1. Class dog. By convention, capitalized names refer to classes in Python. There are no parentheses in the class definition because we are creating this class from scratch. We then write a docstring describing what this class does. The docstring shows a simple attempt to model a dog. So we start with class, and then we do dog with big D to say that this is our class called dog. Okay. Let me go ahead and get some water real quick. Apologies. My water bottle. I'm back. Thanks for waiting. Appreciate the patience. Keep you for waiting. Keeping them company. Alright, so we have a method here, the init method. I'm going to make a note here. So we have underscore init. Okay, like so. this, what did we do? We just gave it a bullet points from like last chapter. Okay, like that. Okay, so the init method. A function that's part of a class is a method. A function that's part of a class is a method. Everything you learn about functions applies to methods as well. The only practical difference for now is the way we call methods. The init method is a special method that Python runs automatically whenever we create a new instance based on the dog class. This method has two leading underscores and two trailing underscores, a convention that helps prevent Python's default method names from conflicting with your method names. Make sure to use two underscores on each side of the init. If you use just one on each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. We define the init method to have three parameters: self, name, and age. The self parameter is required in the method definition, and it must come first before the other parameters. It must be included in the definition because Python calls this method later on to create an instance of a dog. The method call will automatically pass the self argument. So it must be included in the definition because when Python calls this method later to create an instance of the dog, the method call will automatically pass the self argument. Every method call associated with an instance automatically passes self, which is a reference to the instance itself. It gives the individual instance access to the attributes and methods of the class. When we make an instance of dog, Python will call the underscore init method from the dog class. We will pass dog a name and an age as arguments. Self is passed automatically, so we don't need to pass it. Whenever we want to make an instance from the dog class, when we make an instance of dog, Python will call the init method from the dog class. We'll pass dog a name and an age as arguments. Self is passed automatically, so we don't need to pass it. Whenever we want to make an instance from the dog class, we'll provide it values for only the two parameters, name and age. The two variables defined in the body of the init method each have the prefix self. The two variables defined in the self.name, self.age. Any variable prefixed with self is available to every method in the class. Any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. The line self.name equals name takes the value associated with the parameter name and assigns it to the variable name, which is then attached to the instance being created. Oh, so it's just an instance method. That's what it means by instant method. Okay. Water bottle is full of water. Convenient when do that. Okay. Assigns it the variable name, which is then attached to the instance being created. The same process happens with the self.age equals age. Variables that are accessed through the instances like this are called attributes. The dog class has two other methods defined, sit and roll over. Because these methods don't need additional information to run, we just define them to have one parameter, self. The instance we create later will have access to these methods. In other words, they'll be able to sit and roll over. For now, sit and roll over don't do much. They simply print a message saying the dog is sitting and rolling over. But the concept can be extended to realistic situations. If the class were part of a computer game, this method would contain code to make an animated dog sit and roll over. If the class was written to control a robot, these methods would direct movements that cause a robot dog to sit and roll over. Make an instance from a class. Making an instance. They're thinking of a class as a set of instructions for how to make an instance. The dog class is a set of instructions that tells Python how to make individual instances representing specific dogs. Let's make an instance representing a specific dog. My dog equals dog capital D, Willie, and 6. Okay, print f string, my dog name is my dog dot name. Right now I've got age. Okay, so the dog class we're using here is the one we just wrote in the previous example. Here we tell Python to create a dog whose name is Willie and whose age is 6. When Python reads this line, we call the init method in dog with the parameter Willie. Okay, Willie, whose age is 6. When Python reads the line, it calls the init method in dog with the arguments Willie and 6. The init method creates an instance representing this particular dog and sets the name and age attribute using the values we provided. Python then returns an instance representing this dog. We assign that instance to the variable myDog. The naming convention is helpful here. We can usually assume that a capitalized dog like dog, capitalized name like DOG, dog with a capital D, refers to a class, and a lowercase like myDog refers to a single instance created from a class. Okay. To access the attributes of an instance, we use dot notation. We access the value of myDog's attribute name by writing myDog.name. Dot notation is often used in Python. This syntax demonstrates how Python finds an attribute's value. Here, Python looks for an instance, myDog, and then finds the attribute name associated with myDog. This is the same approach referred to in self.name in the class dog. We use the same approach to working with the attribute age. Calling methods. After we create an instance from the dog, class dog, we can use dot notation to call any method defined in dog. Let's make our dog sit and roll over. My dog equals dog, Willie is 6. My dog dot sit, my dog dot roll over. To call a method, give the method name an instance, in this case my dog, and then the method you want to call separated by a dot. When Python reads my dog dot sit, it looks for this method sit in the class dog and runs the code. Python interprets the line my dog dot roll over in the same way. Now Willie does what we tell him to. Willie is now sitting, Willie rolled over. This syntax is quite useful when attributes and methods have been given appropriately descriptive names like name, age, sit, and roll over. We can easily infer what a block of code, even one we've never seen before, is supposed to do. Creating multiple instances. You can create as many instances from a class as you need. Let's create a second dog called your dog. So we have my dog, which is Willie and age 6. Your dog is Lucy, age 3, okay? So your dog equals dog Lucy 3. In this example, we created a dog named Willie and a dog named Lucy. Each dog is a separate instance in which it owns a set of attributes capable of the same set of actions. Even if we use the same name and age for the second dog, Python would still create a separate instance from the dog class. You can make as many instances from one class as you need, as long as you give each instance a unique variable name, or it occupies a unique spot in a list or dictionary. Try it yourselves here. All right. Pardon me. This protein shake is giving me the burps. All right. So we are on the try it yourself problems here. I don't know where to put my book. Let me just put it right here. There we go. That works perfect. Okay, so let's go ahead and we want to make dir chapter 9. We want to cd chapter 9. And then we want to touch 9 underscore 1 underscore rest. Oh, I can never spell restaurant. RESTAURANT dot pi. We want to touch 9 underscore 2 underscore 3 restaurants. Oh no. Dot pi, and we want to code 9 underscore 3 underscore users dot pi. Okay, now let's code all 3 of these. Okay, here we go. So, restaurant pi 911 restaurant. Make a class called a restaurant. The init method for the restaurant should have 2 attributes, a name and a cuisine type. So make a class called restaurant. Miss Kitty, where are you going? You should have 2 attributes. Class has 2 attributes, which are restaurant name. Screw that. I'm just gonna make the daggum class restaurant. Is that how you spell it? AURANT. Yes. Okay, we have class restaurant. In our class restaurant, when we initialize, we're going to take in the self parameter, and then we are going to have a restaurant name. And then we're going to have a cuisine type. Okay. So we have that. Right. So we actually have to say, we have to define the init, right? So we define the init, and then we have cuisine type. So we have to give these, we have to assign these to the specific instance, make them instance methods in this case. So the self.restaurant name is equal to restaurant name, and then self dot cuisine type is equal to cuisine type. Variables are annoying to spell. And a method called describe a restaurant. Okay, so we have a method, def method describe restaurant. Oh my gosh. Describe restaurant, which takes in the self, right? That prints these 2 pieces of information. Okay, print print an f string. We want to print why is, I can't read my thing with that in the way. Okay, f welcome, or this is restaurant. This is the self.restaurant name, the instance restaurant name, and we serve self.cuisine type. Right? Food. Okay. So we have that. Now let me go ahead and actually just make my font a little smaller. Perfect. That's fine. I don't know. I feel like that might be a little too small for stream. Let's go to 20. Okay, that's fine. All right. So then we have another method. It says that is open restaurant. Which takes in the instance itself. And then this prints the self restaurant name is open. I need my okay, maybe like this. Control Command C, delete, maybe here we go. Cool. So there's my class restaurant. So let's just recap what I did. I kind of moved a little quick there. So I have I open up the class by just calling class. I gave the class a name, and by convention, classes are given in a uppercase or title case notation, just so we can visually indicate what is the class name. So the restaurant is the class name. Well, when we initialize an instance of this class with the def init function, obviously it takes in the class itself, but more specifically, it assigns two parameters or attributes in this case to the initialization: a restaurant name, and a cuisine type. And then we just assign these variables to the instance itself of this of the class. This part might seem kind of confusing, but once you just realize that each time this is not creating just one of these, this is creating many things, so you have to identify which one. So this is just a placeholder self, as like saying itself or whatever you call it as. So if I say my dog, or I make a class, it's dogs, right? And my dog would be in this place of self, or in this case restaurant name. Well, your restaurant name would most likely be whatever your variable is assigned to your restaurant. So this would probably be like restaurant one, or probably makes sense to actually have the restaurant name here be like Olive Garden dot restaurant name equals Olive Garden, so because it's just whatever the variable that's holding the instance of the class. This is just a placeholder for that variable. That's a good way to look at it. So we completed that. That prints a message. Make an instance called restaurant from your class. So yeah, it wants us to make an instance of the actual restaurant. So the instance, like I said, is this name restaurant. Yes, our class is called restaurant, but this is creating a instance of this class restaurant, and it is housing, because it's a variable, right? It houses data. And then that's how we access it into these variables, right? Replacing the self with this variable here. Kind of stuttering, geez, yapper alert, gosh. All right. Make an instance called restaurant from your class that prints the two attributes individually, and then print the two attributes individually and then call both methods. Okay, restaurant equals restaurant, and then we give it the attribute name. Let's give it the Olive Garden, right? And then this serves Italian, right? So now if we go ahead and say we want to print, it wants us to print them individually, so we will do that. So we'll have two print cases in this instance, right? And then just to, it wants us to print the attributes inside of the function. So this wants us to print the two attributes individually. This restaurant is called restaurant dot name dot restaurant name. So it looks really confusing because we're using the word restaurant over and over and over again, but once you wrap your head around the fact that we're creating just these restaurants and that when you print, it's difficult to use restaurant here. I can see how that can be confusing because we're just using restaurant here and here and here, and so it seems like all of these are connected in some way, but they're just describing the work being done on the instance of the singular restaurant object in this case. That's at least what I had a hard time wrapping my head around is when David Malin was going over this. He just was words using the word self and you know, in this case restaurant and things like that over and over again, and I thought that they were the same thing, and I just had to really think about it for a while. So this restaurant is called restaurant name. So what this is saying is this restaurant in an F string, so right, this restaurant is called, and then we input our variable because it's curly brackets, and we put in the variable that contains the data of our restaurant class instance. So by convention and by, you know, choice and by how it would be in this case, it is called restaurant. Now I would like to call it, you know, restaurant 1 or restaurant 2, restaurant 3, so they're a little bit more distinguished. Or it'd be probably better to even just call this Olive Garden. So you can, you know, just define it based on the name of itself. But so just restaurant, which houses the data here from our instance created, dot the instance method restaurant name, which is the attribute applied to the initialization. Um, so, which is the same thing as it's just an elongated way of saying we're inputting a variable within a variable. This is a variable we created. This is also a variable that we created that houses the restaurant's name, um, and when whatever the person gives, and then we're just applying it to this restaurant instance. It's a lot of words. It might seem confusing, but just try to think about it, practice, wrap your head around it. Honestly, just keep thinking about it. That's what I did. So next we want to print the I guess it. I'm sure gonna call it Olive Garden. I'm just gonna say this restaurant serves. We already have like the describe restaurant thing, so actually I'm just gonna keep it as this because we have the describe restaurant already. So it doesn't really make sense for us to describe it again. So this will be restaurant dot cuisine type. We just want to print the individual things, right? So this prints the name of the instance of the restaurant, right? And then this prints the cuisine. Oh, I hate these words. Type of the cuisine prints the cuisine type of the instance of the restaurant. Right? So now we want to actually print or call our functions on the restaurant, so which in themselves have print functions within them. So we want to call those methods. So in order to do that, we need to just do restaurant, no, not resource warning, restaurant dot describe restaurant, right? And then do you do parentheses at the end? Yes, you do. There's an describe restaurant, and then we want to also call restaurant dot open restaurant. I'm going to actually do the open call before, because it just would make sense to open the restaurant before we describe what they serve. So the restaurant dot open restaurant. Okay, move fast there again, but let's just quickly go over what we did. So like we said, we created the class restaurant using capital R. We initialize the class by accessing the class itself. We give it two attributes, restaurant name and a cuisine type. We assign those variables, restaurant name and cuisine type, to the instance of the class itself that's being created, so that the instance can access these through these calls down here. We have a couple of methods. We have a describe restaurant method, which just takes in the parameter of the instance itself, and then just basically prints out this is the restaurant name, and we serve this cuisine type. All right, and then in our second method, open restaurant, which takes in the method self, we print the self.restaurant name is open, just simply declaring that it's open. So we create the actual instance of our class now. Now we're actually doing something with our class. We're actually working with it. We were having all these preliminary factors of what is going on behind the scenes, but now we're actually going to use it. We're going to create one of these. We're going to create a restaurant. So we create a restaurant and we put it in a variable called restaurant, and this restaurant has a name of Olive Garden and it has a cuisine of Italian. We go ahead and line 17 here, print out the actual instance variable that was created via this parameter restaurant name. So we just print out the restaurant name from the instance we created, and then we just print out the same thing with the cuisine type, which is going to physically print out Italian. And then in this calls down here, we're calling the methods open restaurant and describe restaurant and applying them to the actual instance we created, restaurant. Yapper alert. I know, crazy. I am going off the rails here, but let's go ahead and run this. Olive Garden, Italian. Olive Garden is open. This is Olive Garden, and we serve Italian food. That's good. That was good. That felt so good. Doesn't it feel good? Just like to have it work. Oh, that's the rewarding part about coding, is that when it works, it feels really good. But when it doesn't, it's so frustrating. But when you finally just have it work, just right off the jump. I didn't even have any typos in there either. Knock on wood. This is linoleum, but or probably carved. I don't know what it is. So I didn't really take any notes here, but I will go back and apply some notes. But so far, this is making some pretty good sense. Yeah. All right, so we're going to move on to 9.2.3 restaurants. Start with your class from exercise 9.1. Create 3 different instances from the class and describe restaurant for each instance. Okay. So let me import. I bet you I can just import restaurants. Oh my gosh. Import restaurant? No. Why can't I just import restaurant? Missing imports. Why can't I call this? AURESTAURANT. Right? I'm just gonna copy this. Because I'm spelling it wrong. I don't think I am. Import restaurant. Okay. I'll make a restaurant here. Let's just do the Olive Garden again. Oh gosh. And then let's do, we want to give it Italian. Right? Let's just, why doesn't my import function here work? Let's see here. No module name restaurant. Why can't I import the class restaurant here? Whoops. Time to go to ChatGPT. How to import a class. I've done this before, but oh, I'm missing a statement. No, I guess it has to be the file, right? Why doesn't that work now? What? Oh boy. Why can't I import this? What the heck? I can't run this either. A module in chapter 9. Am I really gonna have to ChatGPT this? So annoying. The file name is 9_res. Oh. Can't import with a number out front. That's a bummer. Okay, well, I didn't know that. Learn that. Okay, so let's just import this then. Whatever, screw it. There it is. It's imported. So Python won't allow me to import, from um, wait, well, let me just do import materials. I couldn't import. I couldn't import it either way. Hold on. Let's see. No. Okay, so that's fine. We have restaurant one. Start with your class from restaurant. Create 3 different instances of the class and call describe restaurant for each instance. Restaurant 1, restaurant 2 is equal to restaurant. This will be what restaurant? Chipotle. Love me some Chipotle. This is Mexican food. And restaurant 3 is assigned to restaurants, and we're gonna make this name McDonald. No, not a restaurant. That's fast food. It is a restaurant, but I want something you can sit down in. Wow. This is American. Well, is it American? I think hamburger is from Germany. It's from Germany. The hamburger. It's the French. This German accent. It's a hamburger. No, I can't do it. I can't. I don't know. McDonald's. American. I'll do this. Love me some Red Robin, which is American. So let's just call this 2 more times. And then we'll just change the variable over to 2 and 3. Let's run this. And bada bam, let me go here, clear this out. Boom! This is Olive Garden, we serve Italian food. This is Chipotle, and we serve Mexican food. This is Red Robin, and we serve American food. So, I'm not sure why the title case is. I'm going to come over here. Cuisine type. I'm going to give this a dot lower method. So now, if I go over to this guy, clear it out, it should print those in lowercase. No, wrong. That worked. Oh, I didn't import the class. I just copied it over, so I gotta put it here too. Boom, there it is. Boom, this is Olive Garden, we serve Italian food. This is Chipotle, and we serve Mexican food. This is Red Robin, and we serve American food. Alright. Let's go ahead and clear this guy out. We want to go ahead and open up 9.3. 9.3 Users. Make a class called users. Create two attributes called first name and last name, and then create several other attributes that are typically stored in a user profile. Okay. So we're going to first start off with just calling our class, and then we want to call it users. Right? And then when we initialize it, we want to, I always forget to def initialize with self, and then it's a username, user, not users, first name, last name, right? Then create several other attributes. Then create several other attributes that are typically stored in a user profile. Okay, so we'll just do a username. What is else is in user profile? Username. Password. No. Age. Yeah. Sure. Username and age. That works. Make a method called describe user that prints a summary. Make a method called describe user that prints a summary of the user's information. Make another method called greet user that prints a personalized greeting as a user. Alright, so self dot first name. That's a first name. Right? Self dot last name is equal to last name. Keep doing that. Self dot username is equal to username, and self dot age is equal to age. Right? So then we need to def describe user, which takes in the class itself, and then prints out just a string that says user self dot username. New line backslash tab. Self dot first name, new line, new tab, in hyphen self dot last name. Right? We want to new line tab in. We want self dot age. Right? How do you, I think you have to go like this. keep it open? How do you keep the F string open? Just like that? Yeah, I guess. Did it not start with a hyphen? No. I guess you can't start with a hyphen, but you can continue like so. Whatever. So this might seem kind of cryptic, but I'm just printing the usernames, the class's username. I'm printing and then I'm going to a new line. I'm giving a colon, going to a new line, tabbing in, giving a bullet point just via a dash, printing the first name, new line, tabbing in, bullet point, the last name, new line, tab in, bullet point, and then the age. So then, right. So describe user that prints a summary of the user information. Another one called greet user that prints a personalized greeting to the user. So def greet users takes in the self, right? And then we print hello. Self dot first name. Oh. Self dot first hello self dot first name dot dot dot. Yeah, also known as AKA the first name, last name, also known as self dot username. Cool. So now we have that. So now it probably wants us to create some instances of the user. Create several instances representing different users and call both methods for each user. Okay. So user 1 is equal to user, I guess a name, first name is quote, I'll get my own. Cool. Naming. Username is going to be Michael Dems. And then age, well, I am 25, getting old. Alright, user 2, okay, let's go ahead, user, I'm just gonna copy these over. User 2, user 3, this user's name is gonna be Matthew. Let's do Johnson, Matty J, Matty John. He's gonna be 30. And then user 3 is gonna have a name of, let's just do like Phil. Let's have a last name of Smith. Let's have a P. Smitty. P. Smitty. And then P. Smitty, well, he's gonna be an old buckaroo. He's gonna be 86. All right. So we want to go ahead and call the describe and greet user on both of them. So user 1 dot describe user, and then user 1 dot greet user. We want to highlight both these lines, duplicate them down, go to user 2, and then user 3 and user 3, and then let's go ahead and save this, and we won. Alright. Cool. So we described you, Michael Dems, Michael Deming, 25. Hello, Michael Deming, aka Michael Dems. Matty John, Matthew Johnson, 30. Hello, Matty Johnson, aka Matty John. Ooh, got a bug on my screen. Get out of here. Get out of here. Hello, and then P Smitty. So let me actually just add one quick thing here. I'm just going to create print functions in between just so I can do that. So now if I just give it some separation in between each user. There you go. So Michael Dems is the so remember it comes with username. Michael Dems, Michael Deming 25, hello Michael Deming, aka Michael Dems. Matty Johnson, Matthew Johnson 30, hello Matthew Johnson, aka Matty John. P Smitty, Phil Smith 86, hello Phil Smith, aka P Smitty. Awesome. That was 9-1, 9-2, and 9-3. Alright. Alright, I think I'm going to take a break here. This was we're halfway through 162 into page 162 in chapter 9. We have quite a few pages left in chapter 8, or chapter 9, sorry. It goes to 181 is the last page. So we got about 20 more to go for this chapter, but I think we'll make good progress on it later. But yeah, I learned a lot about classes today. Really solidified, the whole instance variable based on a parameter, instance methods, things along those natures, and then actually creating instances of the class itself, and then, calling those instance methods onto those instances. A lot of the same word over and over again. You got to familiarize yourself with the vocab because it's pretty key for these things, I think. But yeah, this has been a study session for tonight. See you guys.